As we can see, we have a table, and that's displaying age, boys, girls, and a total. And here, for basic probability, as we're trying to find the probability of selecting any child. So we have a total population and any child. So the probability of selecting one child out of the total sample. So the total here is 5,290. Probability of selecting any, which is one child out of that number. So 1 divided by 5,290. Now on the next slide, we'll talk more about basic probability, and as we give more examples, and we'll get into conditional probability. In reference to the last table from the last slide, for basic probability, starting from the probability of selecting a boy in the entire sample. So we know the total sample is 5,290, and probability of selecting a boy, so we count the number of boys that we have. We have in total 2,560 boys. So for that probability will be the total number of boys over the total number of people. So 2,560 over 5,290. Now the probability of selecting a boy that is age 10. Now here we look at the total number of boys that are age 10 over the total number of population. So there, 418 boys are age 10, and we divide it by 5,290. Now as we get more specific, probability of selecting a child that is at least 8 years of age. Now we have a different probability here at hand. So what we're going to do is we're going to add all the children, right, from age 5 to age 8, and we will add them up. So boys and girls together, because it says a child, so all the children from 5 to 8. And as we add up the boys and girls for age 5, we've 846, and we add the boys and girls for age 6, 881, and we add the boys and girls of age 7, 918, and the total is 2,645, which we divide by the total number of population, 5,290. Now this one seemed a little bit more complicated, however, it's in the wording. So every time in biostatistics you hear at least, then it's telling me less than that number, less than that 8 years old. That's why we did 5, 6, and 7. In conditional probability, it's the probability of outcome in a specific subpopulation. So here, still looking at that table, here, what's the probability of selecting 9-year-old from among the girls? So which translates into probability of selecting 9-year-old, and the subpopulation will be girl. So what we're doing is, when you look at your table, girl will be your total population there, which is 2,730. And then we look at the table, we see how many girls, 9 years old, which is 461. And that's what 461 over 2,730. Now, the next one, probability of selecting a boy from amongst the 6 years old, among the 6 years of age. Now, which means what? As we're looking at the 6-year-olds, so we look at the table, age 6, the total population of the 6-year old children, so boys and girls together, right? Because that's the subpopulation is 6 years of age, which is 892. Now, how many boys are 6? 379. So 379 divided by 892.